Nice. Test, test. Mic check. Like that. That's not working. So my link doesn't work very well. So stream URL backup. Well, crap. That's not good. Okay, still going. So stream key, stream URL, backup server URL. Well, figured it out. Okay, so this is what I need. I need to do this quick. Boom. Boom. Boom.
Yeah, look what country breakfast is
I have quite a few who are trying to get a bunch of emails. I should fix it. Still not working. So let me try this.
I can help
Well, I think most of it is just getting the restrictions off of it. Apparently it's still restricted. I don't know why. Just made it public. Why? Public. Reviewer. Are they all me? No! Hey! Oh, on your phone? Dang. Also, I want to know how live this is, because I see a lag time on my screen. No, school computer, that's good. Non-school account on phone. Yeah, it sounds like it's somehow I need to enable it, approve it for students. Right. Which I'm not sure how to do that. I'll troubleshoot that. Anyway, good to see everyone. I assume that most of us, if not all of us, are here to get a little help with limiting reactants. 30 seconds late. Okay, good to know. And so, since there's a 30-second lag time, I'll be checking the chat regularly, but I'm just going to work an example problem on my screen, and that's how we're going to proceed. So hopefully, let me see. There we go. Get my screen set up. That works. Okay, so I've got my eye on the chat. Hopefully you can see that on my screen, and so I'll be monitoring that. If you have any questions, type it into the chat. At this point, if you're following along, first of all, welcome. Thanks for joining. This is new for me to do the YouTube Live, and so thanks for helping me out with getting the link and figuring out who it's approved for, who it's not. At this point, you should have watched this video, which is so far my number one pick for limiting reactants, because this person solves them the same way I do. There are multiple ways to figure out which of your reactants is your limiting reactant, but this person takes both your reactants, figures out which one makes less, and then whichever one makes less, that's the limiting. There are other ways to do it and figure out how many moles of each reactant you have, and then use the mole ratio to figure it out that way. I find that conceptually, just solving both and finding out which one makes less is the best way that I've found to solve limiting reactant problems. Okay. In general, limiting reactants, as you read, is just about finding out which reactant runs out first. And so in our example here, I've got a nice visual where I've got oxygen and hydrogen, they're reacting, and after the reaction's done, it looks like I've got some, depending on which one's which, the reds are going to be the oxygens, and so my oxygen's left over. That's my excess reactant. It's in excess after the reaction is finished. So my limiting reactant is the hydrogen, in this case right here. That means that if I'm given an amount of both, in this case 10 moles of hydrogen and 7 moles of oxygen, the hydrogen is going to be the one that dictates how much product I'm going to make. So the oxygen is not helpful for figuring out how much actual product I'm going to make. And so that's why we solve two problems and find out which one makes less product. So here's an example. This one's straight from the Khan Academy practice that you're doing. I've got the due date set for Friday at 8:30 in the morning, just so that everyone has enough time to get this figured out and to submit something that they can be proud of. If you have to try multiple times, that's fine, but our goal is by the end of the week to be able to solve these on our own. It's nothing new. Stoichiometry, we're just going to do it twice. Okay, and so let's look at this problem right here. We've got copper and silver nitrate. It says how many grams of silver will be produced from 5 grams of copper and 1 gram of silver nitrate. And since both of our values that were given are in 3 significant figures, we're going to end with 3 significant figures at the end. Do me a favor, anyone, type something in the chat as soon as you hear this so that I can at least know that it's still working. Okay, here we go. I'm going to do 2 problems. I'm going to devote this one to copper, and this one, just one on top of the other. This one's going to be, I'm going to solve for silver nitrate. Silver nitrate, okay. And I'm hoping, now I'm checking the chat to make sure that it's actually still working. There we go. Thank you, Iman. Okay, here we go. Silver nitrate. Alyssa, excellent. So I've got 5 grams of copper. So let's start with 5 grams of copper. Oops, I don't want that. I'm just working with a blank PDF. I don't want that either. There we go. Here's my 5 grams, 5.00 grams of copper. I need to first convert that to moles. So here I'm dragging in my little stoichiometry problem. know I've got a stoichiometry protection, maybe mole train. There we go. Yay! Hey, normal stoichiometry. I'm given a mass, and I'm asked to find, in this case, a mass, how many grams. And so I'm going to use my mass of A, in this case copper, in order to find the mass of B, which is going to be silver nitrate. Nope, silver. And so I'm going to convert all the way to silver. It's going to be a 3-step problem. Okay. And so up here, I'm going to need the molar mass of copper. I look at my periodic table. I see that copper is 63.55 grams per mole. 63.55 grams for every 1 mole. Okay. Now I need the mole ratio from the balanced equation to figure out, or to go from moles of copper to moles of silver in this case, since it's asked me to find silver. Now, in order to find the limiting reactant, I could use either product as long as I do both problems the same, solve to the same product. But since it's asking me eventually to find grams of silver, then I want to use silver because that's just going to make my life easier. So let's do that. Mole ratio is a 1 to 2 ratio. And so I know that every 1 mole, and let's label units here so that we can see our units cancel. Copper. 1 mole of copper. That way, whenever we go to cancel our units with the mole ratio, we can see our units cancel. A lot of people like to, or accidentally flip the mole ratio, and that's just one of the common mistakes that people make. Comes from not labeling your units. AG. Hey, Caden. All right. Now, I'm going to take this to grams. I've got my periodic table, grams of silver. The molar mass of silver is 107.87 grams. Little guy's coming over here. You guys want to see Calvin? Hey, buddy. There's little guy. Calvin, we're doing stoichiometry. Here we go. 1 mole of silver. Can you see him? Let's see. Let me check my screen. Oh, no, just top of his head. There we go. That's what everyone wants to see anyway. Okay. Yeah. All right. Back to mama. Get rid of these. Why does LPS block zoom? Great question. I'm sure they have a good reason. But I don't know it. I need to get rid of these guys, huh? Bye-bye. I need to get my... There we go. Can I get rid of this one too? Driving me crazy. Go away. Good. Calvin the Adorable. Yeah. Thanks for being patient, guys. I know it takes kind of a while to get this done. Oh, I'd like to select all of this, but it's not going to let me. That's okay. Let's solve this later. It's all set up. My units cancel. Grams cancel grams. Now I'm in moles of copper. And capitalization matters. I would hate to reinforce bad habits. There we go. Grams of, let's say, silver so that everyone's free about, or clear about what we're talking about. Okay. Boom. There we go. Silver nitrate. Let's do the same thing, but instead we are going to find out how many grams silver nitrate would make. So we were given 1 gram of silver nitrate. By the way, if you see any mistakes, shout them out in the chat. go. This is 1 mole of silver nitrate, 1 mole of AgNO3. I'm not going to do subscripts. Molar mass of silver nitrate. Silver is 196. 107.87 plus nitrogen 14.01 plus oxygen 16 times 3 196.88 196.88 grams per mole. Okay, we know that that's of silver nitrate. Oh, that was a mistake. There we go. Boom. Mole ratio between silver nitrate and silver is 2 to 2. We know that that's not going to affect anything. That's a 1-to-1 ratio, but just so that we're all clear, after all this is said and done, we're going to show that. Make 2 moles of silver, 2 moles of silver nitrate, and of 3. There we go. And finally, molar mass of silver nitrate, of just silver. Whoops. Mass, moles. All right. I'm sure you get the idea by now. Here's where we make our money. We're gonna now plug it in. And what we get. Let's go with copper first. 5 times, I'm going to do every single one just to show what I'm doing, times 1. I'm multiplying all the numerators across here, times 2, times 63.55. Is that really silver? No, of course that's not. There's mistake number 1. Sorry, I don't have the chat pulled up. I'm sure you're yelling at me. No, you're not. Well, you should have been. Silver is 107.87. 107.87. I'm sure it's the lag. 7.87. That's not going to help. I'm sure I'm going to get better at this as time goes on, but I would like to. Oh well. Dang. 5 times 1 times 2 times 107.87 divided by 63.55 divided by 1 divided by 1 equals. I'm going to do this to 3 sig figs, 17.0. 17.0 grams of silver. All right, let's find out how much my silver nitrate will make. Put our answer down here. One times 2 times 107.87 divided by 196.88 divided by 2 divided by 1. 0.548. All right, so what do we see? We see that, and does this seem right? Yeah, it makes a lot of sense. It makes sense that our silver nitrate is going to make a lot less product than our copper. I'm getting that from the fact that silver nitrate is a much more massive compound than the element of copper. Molar mass being 196 versus 63. And so the fact that I'm using less silver nitrate's bigger, so less. It's going to take more to get to a mole of silver nitrate, and silver nitrate's being consumed twice as fast as my copper. It takes 2 silver nitrate for every 1 copper. All those things taken together, and I could have predicted that silver nitrate was going to be my limiting reactant. And I can see that that clearly is the case. It makes far less silver than my copper. So what's going to actually happen in this reaction? Well, this copper and the silver nitrate is going to react, and it's going to have a ton of this copper left over. Copper is my excess reactant. All of the silver nitrate is going to be consumed, and if I wanted to make any more silver, I would need to add more silver nitrate. Adding more copper to the reaction is not going to do anything because I've reacted all my silver nitrate. That really is what limiting reactants is all about. I've got, in this example, I'm making some cheese sandwiches. I know that every 2 pieces of bread and 1 piece of cheese makes a sandwich. Well, it doesn't matter if I have a ton of cheese in there. That's going to be left over. And if I want to make more cheese sandwiches, I need to add more bread. You need to add more of your limiting reactant in order to make more product. Your limiting reactant controls how much product you make. All right, well, let's see. I can plug this into Khan Academy. Where is this? 8.11. No, this is a different question. Thank goodness. All right. What did I get? That's not good. What do we got here? Well, I must have made a mistake somewhere. The question is, where? Pulling up my chat. Nope. Let's try this. How do you find which element it was the limiting reactant? Great question. Of these 2 reactants, one of them is going to run out first. The way you find out is by solving for both. So you see how I solved for 5 grams of copper and 1 gram of silver nitrate. I solved both of these. And whichever one makes less, that one, whatever one made less, was your limiting reactant. I'm guessing I did my molar mass or something wrong here. What's going on? Why do I have the wrong answer? This is the same problem, I assume. Yes. The correct answer is 0.635. Silver. Let me check my molar mass for silver nitrate. That is silver nitrate, 10787. Okay, so that's good. Oh, wait, 19688. 16988. There it is. Thank goodness. 6988. Let's find that. Time to fix this. Boom. That's better. 0.635. Close call. 635. Boom. And that is what we end up with our answer. Okay. Getting the chat pulled up. That is a limiting reactant problem. I solved for both reactants and figured out which one made less. The one that makes less has to be your limiting reactant. Just like if I were to look at these cheese sandwiches, I could easily ask, I know that there's 2 pieces of bread for every 1 piece of cheese to make 1 sandwich. If I said I give you 10 pieces of cheese, 8 pieces of cheese, that's as high as we can go, and 2 pieces of bread, how many sandwiches can you make? Well, you would instinctively say 1 sandwich. How did you know that? Well, you, in your head, are able to say, well, 2 pieces of bread will make 1 sandwich. 8 pieces of cheese will make 8 sandwiches. how many sandwiches can I really make? Well, just one, because I only have enough bread for one. That's the same thing we're doing here. We're saying which one is going to make less product, sandwiches, and whichever one makes less, that's your limiting reactant, and this is how much you actually will make. There are other ways to solve for limiting reactants, and so if you watch a video and the one that they explain to you makes sense, that's fine. A lot of times they'll just have you convert both reactants to moles, divide those by the mole ratio, how fast they're being consumed, and that works. It does work. This conceptually, I've had the most success with over the years, so that's why I do that. All right, I'm going to check on this stream here. How are we doing? Still have. Hey, Iman. I think it might just be you. Good. I'm glad the bread cheese analogy is helpful. Yeah, conceptually, when we convert it to chemistry, a lot of times we're throwing mole ratios and molar masses around, and we forget, or it's just easy to miss the concept. Yeah. There's also other good, and I know you get it now, but there's a guy, Tyler DeWitt, who explains it really well. And so that
in this video, we're going to talk.
He does something pretty similar.
We're going to talk about
cheeseburgers is what he uses, but you can look up that video if that's helpful for you. All right. Well, if you need any more tips or any more explanation, then I'll be available on email, and that's how all field does. Oh, I got a like. Look at that. I'm YouTube famous. Anyway, this is where we'll end the stream, and thanks for joining.